Hi everybody, thanks so much for coming here to this presentation. Today we're going to talk about how AI, specifically large language models, aka LLMs, can be used to generate parametric CAD. Before I start, I'd like to give a quick intro to who I am. My name is Kyle, I'm a second year undergraduate at Georgia Tech. I'm majoring in mechanical engineering, but I do a lot of electrical engineering and computer science on my own time. I've been here at Ansys for 15 months now, working on the cloud simulation team under what was OnScale. It's been really fun so far. So I'd like us to all rewind about 2 years to when ChatGPT was first released. I don't know about you all, but my first feeling was excitement and fear. I thought that we were at the brink of a computer uprising and we'd all be jobless within a few years. Luckily, that wasn't the case, and that's largely in part due to the way that LLMs work. When you ask ChatGPT a question and it responds, it doesn't really know what it's talking about. It's effectively guessing what word is most likely to come next, and then it strings word after word together to make a sentence. Now, some people argue that this isn't too far from how humans converse, and that may be true, but there are some clear strengths and weaknesses to this approach. Still, regardless of if the computer is actually thinking, having any logical intelligence like this is extremely powerful if you know how to control it. One of the first things I asked ChatGPT to do when it was first released was for it to create a self-portrait using Python. I don't have the actual result, but I created something pretty similar using an old OpenAI model. That's what you see over on the left. When I first did this, my fears about a computer uprise were mostly relieved, but as time goes on, the spatial awareness and ability to make self-portraits has improved a lot. This is when I started wondering if LLMs could be used not just to draw little characters, but if it could also generate 3D models. I saw that LLMs were really good at writing code, and if their spatial awareness abilities continued to improve, this could be really interesting. And even more surprisingly, nobody on the internet seemed to have tried this yet. So this breaks down into two main challenges. Firstly, I need a way to create CAD models through a programmatic interface that isn't overly verbose. And then secondly, I need to teach an LLM how to use this interface. There are some 3D modeling libraries in Python, but a lot of them are pretty complicated to understand and lack flexibility. For this reason, I chose to make my own library called OnPy, which talks to Onshape through its public REST API. My main goal was to make this library as simple as possible to build 3D models. On the right, I have an example of what some OnPy code looks like. You can see how some sketch entities and features are defined in a relatively simple way. One thing I get asked about a lot is why I didn't just use FeatureScript. If you're not familiar with FeatureScript, it's a way to define custom Onshape features using Onshape's proprietary scripting language. FeatureScript is powerful, but its intent is to be for defining new features and/or automations. It's not really meant for creating entire models. In theory, you could build an entire model through FeatureScript, but the output would be compressed into a single feature. You lose out on the parametric aspect of the CAD. And as I noted here at the bottom, LLMs aren't very familiar with FeatureScript. Almost every time they try to write it, it contains some syntax error or some non-existent function. So now that we have an API to talk to a CAD platform, how do we get an LLM to write this code? So I asked myself, what would I do in this situation? And it really breaks down into 4 parts. First, I'd ask myself if OnPy could even make this model. OnPy has a lot of limitations, considering it's a third-party, reverse-engineered API developed by one person, which is me. If I wanted to create a rocket engine, I'd be hard-pressed to do that with OnPy. Secondly, I'd want to figure out what calculations I would have to do. For instance, if I wanted a circle with a circumference of 3 centimeters, I'd have to convert that into a diameter and then convert it into inches, or whatever my modeler is configured to. Third, I'd lay out a plan as to how I'd want to model this. It's important to have a plan before you pick up your keyboard, especially if you're trying to set yourself up for success. Finally, after all of that, I would end up converting my plan into OnPy code, but I would need to have a good reference laying around so I'd know what to write. So now we need a way to get an LLM to do all of this, which isn't easy. There are quite a few tools we can utilize to optimize our chances of success, so let's go over those real quick. Some of y'all might recognize some of these, they're getting pretty popular right now, but just so we're all on the same page, here's a quick refresher. Prompt engineering, also sometimes called context engineering, is an umbrella term for changing your input to the LLM to get the best result. Prompt engineering can take a lot of forms, and we'll talk about those in a second. Prompt chaining is the concept of connecting multiple LLM prompts together. So, for example, if an LLM needs to perform 2 tasks, you might split these tasks apart into different prompts and then chain them together. Then, unlike prompt chaining and prompt engineering, fine-tuning actually modifies the large language model you're calling to respond in a particular way. The results from fine-tuning can vary, but it's often used alongside these other strategies. Finally, there's retrieval augmented generation, also known as RAG, which has gotten really big over the past year. So, for example, if I say big pink unicorn, RAG allows me to target documents in a database that contextually correlate with large size, vibrant colors, and magic. It's pretty hard to explain without getting into how LLMs and embedding matrices work, but the main point is it allows you to retrieve contextually similar information to a user's prompt. You can use this alongside prompt engineering to gather extra information retrieved from a database that will be helpful for answering a user's question. In context of what we're trying to do with OnPy, we could retrieve examples that are similar to the user's request so that the LLM has something to reference. All of these strategies get pretty advanced, but they all work together to improve the LLM's output. Now let's pivot back to CAD generation. The schematic on the right is the chain for Polybrain, which is the project I've been working on. This uses a lot of prompt chaining, as we discussed, but it also uses agent chaining. Agents can be thought of as an LLM instance that has its own prompt chaining. Each agent has one specific task, and the structure kind of mocks an engineering team. This should make a lot more sense once we delve into it. Here at the top is the pessimist, which is the first line of defense. As its name suggests, the pessimist will be pessimistic about the capabilities of Polybrain. For example, if I asked Polybrain to make a fully detailed model of a Toyota Tacoma, the pessimist would reject the request and ask the user to alter the response. The pessimist will engage in a conversation with the user until it feels like the request is realistic. Then it'll summarize that conversation and pass it down the chain. Next is the mathematician. This agent looks at the summarized prompt from the pessimist and it will decide if any calculations are necessary. If there are some calculations that need to happen, it'll use Wolfram Alpha to perform them. If you're unfamiliar with Wolfram Alpha, it's like a calculator that just has a lot of features. Finally, after the mathematician is done, it'll add some math notes to the prompt and again pass it down the chain. Next comes the executive planner, which is the heart of this process. This planner has the ability to re-engage in conversation with the user if it feels like it's necessary. The goal of the executive planner is to create a plan, which I call the executive report. This executive report will enumerate each step that is needed to create the user's model. It should be noted that the executive planner doesn't write any code. It simply creates a plain English report that'll get passed down the chain. Off to the left is the preliminary reporter. All of these LLM calls can take some amount of time, so to keep the user informed, a preliminary reporter will summarize the executive report and relay the summary back to the user. Next, we'll call the OnPy agent, which is responsible for translating the executive report into OnPy code and resolving any errors that arise. This part of the chain is by far the most complicated, and it still has a lot of development needed. The OnPy agent needs to validate itself, so it interfaces with an image inspector. The inspector uses a multimodal LLM, which is an LLM that can understand images, to check that the generated onshape model meets the expectations of the agent. Finally, there's also an incremental interpreter, which allows the OnPy agent to run chunks of code at a time, validating at each step of the way. Now, much of this hasn't been developed yet. The image inspector is at very early stages in development, and the incremental interpreter is not so incremental right now. Finally, you'll notice a code reporter in the top right. This also isn't implemented yet, but ideally it would send the user updates on each increment of the interpreter. Behind the scenes, Polybrain is written in Rust with the library called LLMchain. Now, most projects use LangChain, and I probably should have too, but the final result is similar. So finally, let's get on to a demo. All right, here's another demo. Over here on the left, I have the console output of the Polybrain. And over here on the right, I have Onshape, and I'm going to talk to Polybrain through its text instead of using my voice. So first I'm going to ask something that's totally unreasonable. I'm going to say, can you create the Saturn V? The Saturn V. I want it to be a one-to-one replica. So first we connect the WebSocket stuff, all, kind of boring. And then we go to the pessimist. And the pessimist is trying to tell us that, it's a good idea, but it's really complicated. And it's asking for a simpler model or maybe like something small in the Saturn V to focus on. So now I'm going to ask Polybrain to make me a lamp, and we'll see how it does. So I'll say, can you create a lamp that has an 8-inch diameter base with a cylindrical, lampshade. The lampshade should be 5 inches tall, and 6 inches in diameter. The lamp itself should be 15 inches tall total. Connect the lampshade to the base using a 1-inch diameter rod. Great. Okay, let's see how it does. So it looks like this has gone through the pessimist. The pessimist liked it, and now it's passing a summarized prompt to the executive planner, which ran into an error. It's going to retry. Great. So we get this little summary here, which says summarize the executive plan, which was up here. So we have 4 parts: create the base, create the rod, create the shade. And then, or I guess it was only 3 parts, right? So those 3 parts get converted into OnPy code, which then get executed in real time, as you can see here. And that's pretty good for a lamp. So it'll ask, does this model meet our specifications? And I'll say, yes, that's great. Now, if I wanted something different, I could say something else. And let's try this. Can you instead make the lamp shade 7 inches in diameter? And now it should go back and try to rebuild this model and make that change. So here we have this new code that it spat out. So it's going to delete the other model. You could make this a little more efficient. And it's just going to rebuild it. And it takes a little time to execute. But that looks pretty good. And if we check, yep, that's 7 inches in diameter. So yeah, that's great. I'll say, yes, that's great. So this kind of iterative process where not only you can check the LLM, but the LLM should, in theory, be able to check itself. So if all of these shapes didn't line up and whatnot, this is where having a photo validator could be really interesting or really useful. But honestly, just asking the user, is this good, can be good enough on its own. Great. So now the question is, what comes next? And I think my answer is not a lot. Prompt engineering develops extremely fast. And the code I wrote for this project, a few months ago, is already pretty much obsolete. So I think I'm going to let prompt engineering and this whole AI stuff kind of mature a little bit before I really delve into this project more. RAG has also been improving a lot. There's a iterative way to automatically use RAG and, prompt engineering to optimize your prompt. It gets pretty complicated, but it's really promising the future of this stuff. Then there's also tool invocations that I didn't cover too much. These agents have the ability to call tools. So an example of this is when the mathematician talks to Wolfram Alpha. Pretty much the agent will respond with say hey, I want to call this. And then we parse that and then send that off to Wolfram Alpha and then do some prompt engineering to provide the Wolfram Alpha response to the agent again. And this has happened so much in all these other projects that OpenAI has started to officially support this. And, now there's a more efficient way to do this. Then there's also OpenAI's O1 model that came out very recently. And this does a lot of the introspection itself. And you no longer need to do your own prompt engineering to get the LLM to talk to itself and whatnot. And then there's image validation, which I mentioned that is in very early stages of development. I should probably say it's not at all developed yet because I've done a little research, but it's very, very new. I'm in school, I'm at Ansys, I don't have a ton of time to develop all this stuff on my own, so image validation has taken a back seat. So yeah, there is a lot of stuff to work on here. I would love to assemble a team, but again, I want to wait until some of this AI stuff develops a little bit more. Here are some links that you can go look at. Polybrain does have a website, polybrain.xyz. It is not affiliated with Ansys in any way. I'm just giving this TechCon presentation because I was asked to, and I do work at Ansys. But yeah, Polybrain is a third-party project. But yeah, thank you all so much for watching. It was a pleasure to give this presentation.